Okay, last section of lesson 1, rewriting literal equations. This is a literal equation is an equation that has two variables at the same time. So it has an x and a y, or a b and a c, or an s and a t, or whatever. It may look unsolvable, but the point isn't to solve for a number, it's to isolate one letter alone on one side of the equal sign. So their first example is 2x plus 3y equals 6. Right, now if this was 2x plus 6, we would just try to solve and find the number. But we're not going to do that here. They want us to solve for y, which means we're going to try to isolate y on one side of the equation. So first off, this y is going to stay locked down for now, and we're going to move this 2x. So that's 3y, I'm going to rewrite it, equals negative 2x plus 6, right? Because I subtracted this 2x, subtracted the 2x, moved it over here. Now I'm going to divide this by 3, because that 3 is multiplying the x. I'm going to divide both of these terms by 3, because each term is independent and needs to be divided by the 3 for it to still equal. Okay. I lost myself. Hold on. That's a y. Sometimes when I draw my y, it looks like an x, and I confuse myself. Y equals negative 2/3 x plus 6 divided by 3 is 2. And now we've got our y isolated. Just like that. Negative 2/3 x plus 2. Put that up there for a second. I hope it makes sense. Okay. Next. Five x plus 30y equals 10. And they want us to solve for x. So remember, we're trying to get that x alone without any numbers next to it, without it being added or multiplied to anything. So I'm going to subtract this 30y, subtract the 30y. 5x equals 10 minus 30y, divide by 5, divide by 5, divide by 5. Each term has to be divided of its own accord. So x equals 2 minus 30 divided by 5 is 6, 6y. And that is our answer. Okay. I'm a little tired of section 1, so I'm kind of zipping through this one a little quick. Alright, fractions. This one's going to get gross. X over 5 plus y over 9 equals 1. And they want us to solve for x. So I'm going to subtract this y over 9, drop that x over 5 down, equals 1 minus y over 9, multiply by 5, multiply by 5, multiply by 5, and that is x equals 5 minus 5/9 y. Why is it 5/9 y? Because this is 5 over 1 times y over 9. 1 times 9 is 9, 5 times y is 5y over 9, so, which is the same as 5/9 y. Same thing. And that 5 over 9 doesn't reduce at all, so we just leave it like it is. And there's that one. Are there any more? Rewriting formulas. Solve. Oh, and then this is why they bring it up, because there are formulas like for area. The area of a triangle is 1/2 the base times the height. And if they give us the area and the base, and we want to solve for height, how are we going to do that? So we would divide by 1/2, divide by 1/2, which is the same as multiplying by 2, right? Because we'll flip the fraction and multiply. So that's 2a equals bh, divide by b, and then h equals 2a over b. See that? See how that works? Okay. Perimeter equals 2 times the width plus 2 times the length. And solve for w. So we're going to subtract 2l, p minus 2l equals 2w. Divide by 2, divide by 2, divide by 2. And we get 1/2 p minus l equals w. Okay. And last one is a word problem. The average dog has a normal temperature of 38.7 degrees Celsius. The formula C equals 5/9 F minus 32 can be used to convert Fahrenheit to Celsius. What's an average dog's temperature in Fahrenheit? Okay, so basically what we got to do is rework this. So we're going to divide by 5/9, which means multiply by 9/5. So 9/5 C equals F minus 32. 9/5 C plus 32 equals F. And they gave us 38.7. Come to me, calculator. 38.7 times 9 divided by 5 plus 32 equals 101.66 degrees Fahrenheit. Huh. A dog's normal temperature would count as a fever for a human. Interesting. And that does it for this lesson and this chapter. I guess you could call it a chapter, chapter 1.